Welcome back, guys. Just one thing I want to make sure that if the multimeter is in our previous test that we've just seen, our multimeter was in that setting there. I'm just make sure when you completed the sequence of those tests in the order which you were shown, that you turn the meter off and you just put it back on the desk, nice and neatly, ready for testing later on, so that you're actually keeping your materials and your gear in good order. Okay, ready for the next user. Very important when you've got your own tools and you've spent thousands of dollars on tools. That type of behaviour will be rather natural, but when you're using other people's gear, as you become part of industry, you'll be expected to treat everybody else's gear like your own. So I'm trying to instill that mythology and that good ethic so that when you go to the workplace, people can see you have respect for other people's materials. Okay, let's move on. Okay, so we're moving on now and we're doing job 3. Job 3 says, as is detailed in the unit skills test sheet, one PowerPoint, which you've already done, one light switch, which we're going to pull this PowerPoint off and do, and one baton holder. All wiring to be enclosed in 20mm conduit, which we've partly done already, both here and here. Saddle, as we've done, fixed with screws, as we've done. And the light switch must control the light. Leave a 300mm tail. We've got a tail already here, that was 400mm before, but that's okay. If it's 300 or 400, that isn't critical. As long as it's long enough, it wants to at least be 300, so no shorter than 300. So we can do our testing and do our livening up on an extra low voltage circuit later on in the test. Ready for a power supply to be connected, okay? But we still have to do a continuity test and a polarity test prior to livening that circuit up. So now we've got to actually disassemble part of the circuit already so we can reassemble the next part. So this is what I would do from now on. So for a start, remove our test plug, we take our cover off, and I'll use my Phillips head screwdriver for this. Once again, do not use a rattle gun on these because you will strip the thread. So just take the time and the effort to undo with the screwdriver. You need your screws a bit later on because it's the same size plate for a light switch it is for a PowerPoint, and they screw into the same fixings of the block underneath it. Okay, so here we are. We take our PowerPoint off. We don't cut the wires off because basically we need to use those wires again for the next part of the circuit. Now this circuit, they'll be drawn up on the board for you how to wire it. So don't worry, you won't be expected to know how to wire it. You'll be following the process that I'll give on the big whiteboard about how to do that. So we just leave our tails ready to go over here for the next part of the circuit. So I think that I've said in job 2 that we want to have a baton holder and a mounting block to the left of the second PowerPoint. So in this case, depending on how you've done it, it could be to the right. If it was from the right over here, your tail would be at this end, of course. So depending where your first PowerPoint is and what side of the bench you're working from will depend on how this is configured. It's either from left to right or right to left, but the measurements and the methodology will be the same. Okay? If you've got questions about that while you're doing that, do not be afraid to ask. So our next bit of conduit that we're going to put on here is going to be 200mm long. That's the first point of call. So I've got some small pieces of conduit right here ready to go, so I'm now just going to measure that again. Get my measuring tape nice and close. And sometimes with your measuring tape, it's just easier to fix it, lock it in position, and basically like so, and just mark it accordingly. Make sure you're sitting on top and just mark it accurately like that. And you can see the mark beside the 200mm there as such. Okay, release your tape measure, watch your fingers as it comes back in. Correct use of the tool again for the cutting of the conduit. Open the jaws wide enough so the conduit sits right back down into the saddle, like so. Crimp it until the jaw meets the line. Then you can let the other conduit because the jaw's grabbing it. Then you can just use 2 hands or one and just give it a little click, it goes into the next serrated or tooth of the actual cutting mechanism. Once you get close to the end, you get your hand underneath it like so, and just go like that, because the jaw won't go down through, it only goes back to the housing, so it won't cut you. You can grab the conduit, put your tool away nice and neatly, double check that you're using the right bit of conduit, and that was not the right bit of conduit, and that's the right bit of conduit, confirmed 200 millimeters like so. It's all good, and now I can put that in the end there like so. Have it so if there's writing on it, the writing faces backwards. Just push it into the block beside it. Now this unit here has got a lid on it, so I'm actually going to remove the lid because I can't screw my PowerPoint or see the wire if I have the lid on top. So we'll remove the lid. Make sure you don't discard the lid or the screws, because if you do, you won't be able to find them, put them back to reassemble it correctly when you disassemble the whole exercise. So make sure you do that. Don't undo them all the way, they're still poking through a little bit. They shouldn't fall out, but that one did. If it does, just make sure you grab it again and just wind in a couple of turns so it bites the lid. You don't have to go searching for the screws later on. Put that to one side. Okay, now we put our block on there, ready to go like that. Now we've got to throw a couple of saddles on this as well. So you see how that's moving a bit there like that? Just make sure that it's nice and straight. You're going to have to visualise that. Get our saddles, screw on, ready at a similar distance out again. I'm a saddle short, so I've got to get another saddle. These saddles are Clipsal saddles, and the catalogue number of these saddles is 180/20. So it's a one-sided saddle. A double-sided saddle would have a screw hole and a little leg on it on both sides of the cup. So it's a single-sided saddle. The brand name is Clipsal. The catalogue number is 180 20. Okay, get that pretty close to being the same. Okay, get a couple of screws, and we use our battery drill with this. Once again, it's not muscle, it's method. I'll come on this side because I'm actually right-handed, believe it or not. This will be a bit easy for me. I just get that nice and lined up like so. I just scan the trigger, make sure it's perpendicular to the screw, else it'll fall off. Okay. In fact, that's a bit crooked, can't that. If you've actually made it a little bit crooked, just move your saddle a little bit one way, and that'll solve that problem. And then you can put another hole in. Okay, that's better, I'm happy with that. Okay, the two saddles in. Looks pretty good. Okay, now we're going to wire it up. I need a tail long enough to go between that switch and that light. I've got a tail ready to go with no ends poking out, so that's ideal. Is that still going to be long enough? Well, probably not. That one's going to come in, so I can't use that one. Get on the tail. Now, as I was talking about earlier, you'll pull some tails out of the bin like this, okay? So if you do, don't cheat. Make the effort, because you're in the learning, remember. This is part of the process. Just cut the excess off. Put the excess into the rubbish, both ends, and then you've got to practice your terminating and stripping your cable again. Don't try and cheat. You're only fooling yourself, so don't be tempted to do that. Okay, so get the cable nice and straight, running your thumb along it and pushing it away from yourself like that, so there's no major bends in it. You can feed it through the conduit like so. And we have a termination end both ends. So don't cut this end off yet. Get all this one ready to go and organised, and away you'll go. So as we said with the PowerPoint before, when you have two wires at a PowerPoint, we twist them together. So as we know this switch, and as you'll work out the switch when you go through the terminations and you see how it's wired, we're only going to be switching the active, which is the red wire. So I'll get this cable prepared, very similar way that I've prepared the rest of them, but a little nick in the outer sheath like so. And we'll strip the cable back to that cut point, like so. Okay, now with this one here, of course the conductors in the light switch and the tunnels in the light switch, which actually crimp on the wire, are only small. We can't bend the cable over. That's our earth active wire, this is our earth wire. Okay, we do a similar thing we did before. We just actually make sure the cables are going to be pretty close to one another, the same length. Okay. And we're pretty good there, so I'm quite happy with that. That's not a bad effort. So I'll get this cable ready to be stripped, like so. I don't need a longer strip section for my active because it's only going to a small tunnel of the switch itself. So that can be a lot shorter than the active and the neutral in the earth, like so. Pick up your little end of your wire stripping of your insulation, ready to go. Okay, now you don't necessarily have to untwist the earth wire to get the earth wire to connect to the other earth wire in a situation like this. So just watch and listen, look at what I do. I line them up again, like so. Other one's already twisted because I twisted it before using the PowerPoint. And quite often you'll see this. It's okay to line up the insulations again and just twist the other one around the outside of the one underneath it, like so. You see what happens? It's bonding, it's a good bond, it's a strong connection. Cut off the excess that you don't need. Go back and twist it up again. Look at that. You would never know that that was what I'd done, one was already twisted. Okay, let's go back to the neutral conductor and do the same thing again. Notice how I'm doing this. I'm laying these cables out so there's very limited crossovers. So try, not always easy just to make it so there is no crossovers, but it is possible to make it so that there's minimal crossovers. Okay, so here we go again. Insulation's lined up. Cross it over and twist it up around the other cable, like so. Cut off the excess again. Ready to go. Okay, that's that, and that's that. Now we've got our two actives. We've got our active supply and our active load there. So that is the switch goes between these two wires here, the two reds. The one on the right is the supply from the power source, and this is our power source here. The one on the left goes to the load, so that's the switched active. So the switch has to control that active so that the switch can control the light. If I join that on there and I put power on here, the light would be on all the time. So therefore we must have the switch break that part of the circuit. So what are we going to do with these? Where do these go? I have seen people, there's actually in the back of this switch there's the common terminal, which is where the source goes, the power supply, and there's a terminal 1, a terminal 2 and a looping terminal. If you actually put a multimeter on it and you do a continuity test on this switch, in the off position there will be a closed circuit between common and 2 and an open circuit between common and 1. In the on position of the switch there will be a closed termination between the common and 1 and an open circuit between common and 2. The looping terminal at the bottom, which only has one screw in it, is always for the common wire that might be another active or a wire doing something else. I've seen people put a neutral in there. Do not ever get even the practice to doing that. Both the neutral wire and the earth wire, it isn't mandatory, but it's really good practice that you remain a really good connection, because what actually happens with the electricity goes out on the red wire, goes through the batten holder, goes through the globe of the batten holder, comes back on the black wire, the neutral, comes back on the neutral wire, comes into this joint here. This has got to be a good joint, comes back on this wire through here, through the power supply, back to the ground. And it goes to the ground because the earth wire is connected to the black wire in the switchboard. So these two wires, this earth wire protects your life if there's any exposed metal part in between point A and point B. The neutral wire has to be good connection because it's the return part of the active feed coming back from the load. So it's the it's the secondary side of the load, not the primary side of the load. And the earth wire is the earth protection, the fault protection, and very important good connection. So it's very important that when you do these connections that we use what you call a double screw connector. Now I'll just go get a couple of those and I'll show you what they look like. The rules book says you should always use a double screw connector, 2 screws, for the earth wire. It doesn't say it for the neutral. I always do it for the neutral when I have a termination in a block like this because it creates a better connection. There's more securing the cable in the tunnel, the little brass tunnel in there, to make a good joint. You can use a single screw connector, which is this one. See, all of them have closed back so the wire doesn't poke through the end. For both active and neutrals if you wish. It's good practice to use as many screws as you possibly can in a termination that you can't have access to or easily access to. Okay, let's use these. We'll put these on next. These have a flathead screwdriver hole in it. So your big screwdriver with a 5mm head, just undo the screws to the point where they're not going to fall out so you can get your wire in unimpeded by the screw. And we do those up. Like so. Yeah, I am recording. I was double checking that, couldn't see it. Do both screws up tight. Make sure you push it all the way in. Make sure the screws are actually on the copper, not on the on the insulation. Can you see? Look at that. See, I'm actually screwing the insulation, and the insulation just enters the first part of the actual plastic insulation and doesn't go under the screw. Okay. Do the same with the second one. Make sure you release both screws fully so that the earth wire can protrude all the way through to the end of the tunnel, the brass tunnel for the termination. And here we go again. Get a nice firm termination. Right, they are done. Just double check that. Make sure that's good. Just QA it again. Yeah, that's good. That's good. Look at that. It's a lovely firm joint. That's what it should be, a lovely firm joint. Okay, now we go to our light switch. Okay, our light switch, I want to tell you a little trick with these light switches. These light switches have the ability either to be horizontally mounted like that, so the long edge is horizontal, or vertically mounted like that, so that the long edge is vertical. If it isn't either case, when you get them out of a brand new pack, they'll always be in the vertical configuration. Excuse me. How do you change that over? Right, so you grab your pliers, not too much force, and just push that one that way, and your pliers in the opposite direction like that, and just flicks out like that. And all you've got to do is turn it so that the switch is now in the correct configuration. So you look at it, I want it to be vertical, so I now just click that back in like so. I push in like that, and now you can see it's in a vertical configuration. We're using it in a horizontal configuration, so I'm going to turn it back around again. If you put screwdrivers in there to try and force them out, you'll actually can break the little tag. And you can break the housing in which the actual mech sits inside, which is a little recess there, a little tooth there. So don't do that, because you'll basically find that when somebody goes to use that switch, they'll end up pushing it back through the plate, and then they'll be calling an electrician to come and fix it for them, because somebody hasn't done it right in the first place. So I need a smaller flathead screwdriver, which I've got one here. Okay, so I'm going to be using the common terminal, which is the middle one at the top there, and terminal 1, which is the one to the left of it, while it's facing me. One could say it doesn't matter because it's switching between common 1, as long as the two terminals are in common 1, it doesn't matter where the source goes and where the load goes. But it does. For testing purposes, it's good practice to always put the common terminal, the word common meaning that it has no other controlling device on it, so therefore it's common something. So in this particular case, it's a common power source. So put it in the common position. Why is terminal 1 labelled terminal 1? It just so happens there happens to be 4 terminations here. One's common in the on position, which is the common switching position, is called terminal 1. Now that's the manufacturer's choice. I have no other explanation for that, but make sure your insulation just enters the top of the actual tunnel. So there's no copper showing. And here, just do the screw up. You can see that some of these screws have been treated pretty harshly by other trainees. So just don't over tighten it, just nice and firm. Okay, like so. And that now is terminated. Have it so that, see the writing there? Have it so the writing faces down, like so. And it's just clear on top. And that is the off position, and that is the on position. Okay, now I've got to put the wires back into the termination, or into the housing. Another good practice to use, you'll find that if this is going back into a wall cavity, quite often there could be silver paper and so on behind the wall. So if there is such thing behind the wall, a silver paper has a metallic surface, or it could be a bit of steel bracing on a bit of timber, or it could be a brick wall, which is also considered to be a conductive source for electricity to flow. We've got to limit that from occurring. So how do we do that? Okay, well, there's several things we can do. This here we have a PVC box which has a back in it, which basically means that the whole back prevents any ingress of any moisture or any other conductive surfaces or airborne subjects or water-based or fluid-based or liquid-based subjects from entering the actual surface of the block. It's not totally impervious to rain or anything like that because it has no rubber seal around it, but it does prevent standard airborne ingress of moisture. So that being the case, it probably has an IP, which is a weatherproof rating of around about 23 or thereabouts. Back to the original statement. The original statement was, how do I prevent this from shorting out with anything or whatever else, or something poking into the screw or whatever? Well, what I generally do is this. I generally tape these up. So I do this as follows. I start with halfway my tape along the end of the actual, so half the tape's going past the end of the actual connector. I go round a couple of times, then I go one past and I wrap it around the conductor and I pull tight, so it joins the conductors together. And then I just work my way around like so. Once I work my way around so, I go one or two past the end of the actual of the connector, and then I just fold that back like so. And then I just go around one more time to hold that fold back against the connector, like that. Now you can be really pedantic about it, and you can cut it with a pair of side cutters, you can pull it off, whatever you do. Just remember you're going to be pulling this tape off again, so don't be afraid, a little bit more pedantic, and have it so you have access to the end so you can untape it again. Okay, that's the neutral conductor done. I do exactly the same with the earth conductor. You don't have to use white coloured tape, you can use any coloured tape. If you want to be really correct, you could use black tape and green tape. But in this situation, because it's an all insulated product, we're using the tape that happens to be with us, and this happens to be a white tape. So there's no right or wrong about that. It's probably just more correct to use the correct coloured tape. Same methodology again, half over the connector, half on the insulation. Let's go around once or twice. Come back on the conductor and pull tight on the conductor, like so. Then come back, up over the screws of the conductor, come past the conductor, the screws, come past the end of the connector, go once or twice past the end of the connector, and then fold that back like so against the back of the connector, then come around one more time. Once again, we cut it so we know that we've got to pull it back off again. We can use our side cutters for this. Get the jaw lined up properly. Okay. And we just fold it back like that. Okay, there we are. There's no way any of these conductors here can short out with any screw there or anything like that. So we're going to be pretty happy with that. Okay, so all that's good. Untwist all this, ready to go. Okay, so now we've just put this back into here. prepare this so the conductors all sit back nice and neatly. We just fold that over like so, it's round like that. We put one of them up the top like that, and we'll have one of them down the bottom on the side. Just remember that our connector is going to go in the middle, so we need to be able to manipulate that so that it all goes back nice and neatly. And that is like that. Okay, it's all good. Confirm that our writing's at the bottom, it is. Start our screws off again. Do not use a rattle gun, I reiterate that. Don't want a rattle gun using these screws against the motor block. You'll ruin the head of the screw, and you may strip the brass housing which holds the screw and contains the thread for the screw to screw up again. It's not a strength test how tight you can do the screw up. Some of the screws are a little bit tight simply because the thread has been manipulated by others, not totally correctly, so just don't force it. If you have an issue, we'll get on the block. Lead switch in the off position. Once you've completed, make sure that it's nice and straight, of which it is, and put our clip on. And there we are. We've got a power point and a light switch now. Now we have to do the light. So here we go. Going to do the light. We'll just pan around a little bit for the light. Okay. That's all ready to go. So we just do the same methodology we're doing everywhere else. We just work out, haven't got a lot of room in here to push the cable back inside. So we go a fair way back towards that outer housing of the actual junction box. We might just put a little crimp on the outside of our cable. Don't bother cutting this off until you're ready to do the stripping and so on. Because the cable's already there, it's already being used, so just strip it right back. Sometimes it'll fall off like that, but don't panic. Just pull it back to where you've made the crease in the outer sheet. Get it somewhere near it. If you need to hold the wire, you can, and you can just pull it off like that. So hold it in the back sheet with your pliers, and so on, and pull it off towards you. Okay, a batten holder, it's got a skirt, which is this bit, and a base, and a lamp holder. Pull the skirt off, push it back through the base, and this is our lamp holder. Our lamp holder has 4 screws. It's got a green one. You can see it, it's got a green one, it's got a red one, and 2 middle ones. The 2 middle ones are the terminations for the lamp. The green's for the earth, and the red one is for a looped active that is unswitched, that might go to another light fitting further down the circuit if there's more than one light on the circuit, which there often is. Same rule applies here again. Release the screws that you need to use for the termination. So we've got a neutral, an active, and an earth here. So we basically need to release those 2 screws, ready for the termination. Okay, the tunnel isn't that big, so you're going to be hard pressed to actually double over a 2.5mm cable and put it in that hole. So I'm not going to ask you to do that. I'm just asking you to strip enough wire off so that the single insulation to go in there. But we don't want to have too much insulation, too much single insulation. So we're going to use the same rule that we use for the PowerPoint. We want about 75mm of single insulation left after you've stripped it. So we just do it by eye. So what I'm going to do, I'm going to cut it around at about 100mm. Now I'm just doing that by eye. Now we can be really anal about this, and we can measure this if you really, really wanted to, but I'll leave it up to you how you do that. I'm going to get on this side of you so I can see, you can see what I'm doing here. Okay, so here we go. Right, there we are. I always strip it longer than what I need because that allows me to twist the wire a bit more accurately, and then I can just cut the excess off. Okay, there's our 3 wires. Okay, so we've got our 3 wires in now. I'll come back over this side because it seems to actually light up better, doesn't it? Looks better. Yeah, okay. It does look better, doesn't it? Okay. Right, so we've got our 3 wires. We'll strip these up, ready to go. Twist them up, ready to go. Start right at the insulation and work your way back to the front of the cable, or the front of the conductor. Get them all twisted up first before you start cutting. Now you've got to work out how long the conductor has to be to go into the tunnel. So you don't necessarily want to push it all the way into the base, but if you want to, that's fine. you can do that. And if you want to measure that, you can just measure one if you want to, and just do this. And just go, okay, push it into there, put your finger where at the edge of the tunnel where you can see, oh yeah, that goes in approximately about 10 millimetres. So you know that the conductor needs to be approximately 10 millimetres long. It doesn't want to be any longer than that. So 10 millimetres is probably slightly less than the width of your jaw of your pliers. So we go approximately there like that. Save all that covering. We just, after we've cut it, we strip and twist it up again. We get them all the same. Doesn't take any effort to actually catch these copper conductors as you go, unless they do that, of course. Spray all over the place. But basically, get all the ends twisted up, all that's good. Now we can terminate that. So it doesn't matter which side of the conductor, the red and the black go to for the 2 middle screws. But let's do our earth wire first. So that goes into the earth termination. You'll see there, my in-situ insulation is pretty well hard up against the actual top of the brass conductor. It's under the screw, and that's what it should look like, something like that. Okay? So I'll go my active to my right, like I did with my PowerPoint, and my neutral to my left. And there's no right or wrong about that, it's just how I'm doing it. You can go the other way around. But because the PowerPoint had the right termination for the active, I make it all the same because you just use the same methodology. And if you start doing something and you always do the same, you just know how you've done it. And it's much more easy for fault finding later on, looking down the track. So you make a little method for yourself. As long as it's electrically correct, you can follow that method with all your terminations, and it's very, very hard. If you do something repetitively, always the same, it's very, very easy to fault find your own work if there's an issue, or to go back and trace something later on if you need to, because you know what you've done, or your methodology in doing so. Therefore, you don't have to remember so much how you've done something. Okay, once that's done like that, that's what it should look like. Neutral, earth, active, with the looping terminal at the back, screw done up, not sitting loose, and you're ready to put the lamp holder back into its housing. And here we go. Put the base on first, make sure the skirt's the right way around with the thread, like that. And don't do it overly tight. Okay, now you just push that conductor back in there like that. Get it so it's nice and straight. Okay, what screws are we going to use? Now you can see that's a metal thread screw there. We don't have the screws long enough for that. Okay, so we've got to manipulate another screw to use it. So we're going to use a bugle head screw, the same as these ones here, but this is a 20, and we're going to go to a 25 mil. That's in the same big Milwaukee screw box. So we go to a 25 mil. We're just going to do it up. We're not going to over tighten it. I'll get a couple of those. Okay, here we go. That's what they look like. Just line one of the screws up. Don't try and over tighten it because you'll strip the plastic thread inside. There's only a plastic thread. I don't want you to do that. Just make sure you line it up nice and neatly. Don't try and over tighten it. Right. There we are. So we just go back and we'll pan it again and have a look. We've got a power source to here, power point, a light switch and a light globe. Okay, so I'm just going to get ready for the globe now, ready for our polarity testing again and our switching testing just to prove that our switch is actually going to work. So I've got to go get a globe for that. Just give me a second and press pause.